So friends, now we are going to discuss about sorting techniques. That is, what are the different types of sorting techniques available in data structures, right? Sorting is nothing but before doing some process by the processors, the data has to be arranged in order. It means we must have to arrange the data in an order so that any of the values can be accessed in an easier manner. For example, if I want to access a file name from a file location or a C: drive, or if I want to access any student informations from a database, it is very needed that all the data has to be ordered in one way or the other so that we can access the data in a very easier manner. For example, it may be in an alphabetical order, or it may be in an ascending order, or it may be in descending order. So all these data organization is being done by the data structure using different types of sorting algorithms. Now we are going to discuss about different types of sorting, right friends? So we have two types of sorting. So it is internal sorting and external sorting. Internal sorting is nothing but we are going to take the data which is being present only in the main memory. I think everybody knows about the main memory. It is nothing but RAM. All the informations that is being present or stored in main memory are sorted so that searching can be done in easier manner, right? Next is external sorting. So what is called external sorting? If the data size is very huge, we are going to get the help of the secondary memory. Suppose if the data size is very enormous, right? So at that time I must have to get the help of some secondary memory, for example pen drive or CD drive and so on, in order to store those data, and accessibility can be done in an easier manner, right? So we have two types of sorting. One is internal sorting and external sorting. Internal sorting is being done for the data that has to be arranged in main memory. Okay, so external sorting is nothing but we are going to sort the data that is being arranged in a secondary memory, right friends? Now we can see these techniques used for sorting the data at the same time, right? So we are going to discuss about what all the different types of internal sorting and external sorting is being available, friends. So we have two types of properties of sorting. So one is stable sorting, then another one is in place sorting, right? Stable sorting is nothing but we are going to sort the data elements based on its relative position. So relative position is nothing but the data that is being present in a nearby area. For example, 10-20% to the nearest location, or 30-10 that is being present in the nearest location. So we are going to make a comparison between the nearby elements and do sorting, right? Some of the sorting algorithms which supports stable sorting is bubble sort, merge sort and insertion sort. All these things we are going to discuss in the future, friends, right? Next is in place sorting. The elements are rearranged in a sorted order within the given space, that is in the same given space, right? So we are going to arrange the elements in ascending or descending order, not only in the relative positions but also the elements that are present in a scattered manner. So in those types comparisons are being made. So in place sorting are also supported in bubble sort, insertion sort, shell sort, heap sort and quick sort. Now we are going to discuss about some of the internal sorting examples, right? This word, for example, HBRISSQ. Okay, so this is a short representation in order to make you to remember easily, right? So you can pronounce it as how HBRISQ. So internal sorting is also can be meant as HBRISQ. So H stands for heap sort, right? See, I have mentioned here also heap sort is H and selection sort is S, bubble sort is B, insertion sort is I, shell is S, radix sort is R and quick sort is Q. So all these things are being shortened and I have written it as HBRISQ, right? So some of the examples of external sorting are merge sort, selection sort, bubble sort, insertion sort. So this I have written in a shortest manner as SBIM, right? SBIM, like this you can remember. So internal sorting can be represented as H BRISQ, you can easily remember, and SBIM is used for external sorting. Now we are going to discuss different types of sorting algorithms that are available. So first one you see, it is bubble sort. One minute. Bubble sort, merge sort, insertion sort, shell sort, heap, selection, and quick bucket and radix sort. So all these things we are going to discuss. So first one we will see about bubble sorting. So the other name for bubble sorting is, we can also call it as, it is a swapping algorithm. If the given data sequence is in random or in unordered fashion, right, it is not in order, so we will sort that values. Let's see with an example. So these are certain elements which are being not arranged in ascending or descending order or in any order, right? So we are going to arrange it based on bubble sorting. So how many elements are being present? 1, 2, 3, 4 and 5. So how we are going to do this is, first take, see I have given the steps for each and every thing that we are going to do here. Take the first element 10 and move towards right to find the element that is lesser than 10. So now find, is there any element that is being present lesser than 10? You just see in this rightward direction. So none of the element is being present. Okay, so value that is less than 10 is 0, means there is no element. Now take the second element 77, so do the same process, which is moving towards right and find the element that is lesser than 77. So the value that is lesser than 77 is 3. 3 elements are present, you see 53, 45 and 61. Okay. Next, take the third element 53 and move towards right to find the element that is lesser than 53. How many elements are present? So the elements that is lesser than 53 is 45. So we are marking it as 1. Now take the third element that is 45 and find the element that is lesser than 45. So none of the element is lesser than 45. What we are going to do is, we are going to collect all those elements that is being lesser than 10, lesser than 77, lesser than 53 and lesser than 45, and we are going to swap those elements in ascending order. So total number of swaps that is being required in order to make these elements in an ordered manner is 3 plus 1, because these are all zeros, we cannot able to take it into consideration. So 3 plus 1 is equal to 4. It means we need 3 number of swaps in order to make these elements in an order, right friends? So number of passes is nothing but 2. See, because this is one area 3 and this is another one area 1. So number of passes that we require is 2. Number of swap is 4 and number of passes that is required to arrange these elements is 2. I think will be clear. So now we will go for insertion sorting. It is a very easy technique friends, right? Similar to shell sort, just make a note. In the next video we will discuss about shell sort, and it uses divide and conquer approach. Okay, so divide and conquer approach is nothing but we are going to take the scattered elements that is being given for us in order to make it in an ordered manner, and then we are going to split in such a way that one of the elements is going to be in an ordered manner, then another element is going to be in an unordered manner, right? Finally we are going to take each and every element and we are going to sort it. See, split by taking out in increasing order of the first elements, okay, in each successive steps as follows. So now we are going to see that step. So these are all the different elements given: 40, 70, 10, 20, 60 and 90. Okay friends, so now see, this is dividing partition which is being represented in an arrow mark. Now what we are going to do is, take as it is being given, take the elements in the increasing order, that is in the left side we are going to arrange it in ascending order by taking the elements from the right side. Take from right, put in left. What is the first element present? The first element present is 40, so add it over here. Okay, now the remaining elements are 17, 10, 20, 60 and 90. Put it in the same order as it is being given. Now take the second element. So second element is being 70. Now see how it is being ordered here, 40 and then 70. It means we are writing it in ascending order. 40 is first, 70 is second. And on the right side, we are writing the remaining elements, that is 10, 20, 60 and 19. So now, what is the next element present? So the next element present is 10, friends, right? So how we are writing? You just watch the left side, ascending order, 10, 40 and 70. In the right side, we are placing the remaining elements. Now you see 20, okay, in the right side, pick it up and write it on the left side. In the ascending order, see 10, 20, 40 and 70. The remaining elements is 60 and 90. See, similarly, you are taking 60 and you are placing it in ascending order. Remaining is 90 and that is also being placed in the ascending order, and finally the right side is going to be in an empty. Okay, so now the elements are being sorted are 10, 20, 40, 60, 70 and 90, friends, right? So now we are going to discuss about quicksort algorithm. Okay, it is an unstable algorithm. It means we are going to arrange the elements that is being present in any of the locations. But in bubble sort, we were doing a nearby comparison. Can you just follow? Right. Now, quicksort is called as partition sorting algorithm. Right? We are going to partition based on pivot element. Okay, pivot element. See, we will discuss it with an example. Should place one element in a position and partition the remaining elements into two sets. Okay, take the first element. See, pivot element we can choose as any one, but basically or majoritively we will be selecting the pivot element as a first element that is being present in the given set of elements. See, this is the way we are going to arrange. Smaller elements in the order, pivot element is being placed in the middle, larger elements in the order, right? This is the position. See, left partition, the removed, that is I am talking about this one, smaller elements in the order. This is called as left partition. The removed bigger element is placed before the pivot element at each step. Keep this in mind, friends. Next is right partition. I am talking about this side. Okay. Right partition is the removed bigger element is placed at the last after the pivot element at each step. That you will be able to understand. Please make a note of these 2 points. So these are all the given elements: 26, 10, 13, 30, 35, 45, 92 and 60. Now, for example, here I am choosing 35 as a pivot element. Normally 26 will be chosen in order to make you to think that we can choose pivot element as a any one. Now, this is my pivot element. Okay, now take all the elements that is being present lesser than 35. So, write in the same order, friends, 26, 10, 13 and 30. So, these are all the elements that is being present less than 35. Next is, you see, elements that are larger than 35 is 45, 92 and 60. Okay. Now, take the next bigger element in the left side. So, 30 is a bigger element when compared to that of all the 4. Write 30. Okay. Then 26, 10, 13 is the remaining elements that we will be discussing, seeing it in the future. So, 30 is the biggest element which is being returned before the pivot element. So, now you see in the right side, okay, which is the biggest element, 92. So, 92 is placed at the last. Okay, remaining elements left out are 45 and 60. So, now next bigger element is 26. Okay, next bigger element is 26. Now we are removing it from this group and I am separating 10 and 13 from the group, right? Now the next, see, 30 is already being split, 35 is a pivot element. Can you follow, friends? So 26 is the next bigger element from this partition. Okay, so now see the right side. The next bigger element is 60. See, sorry. So 60 is placed in the before position. Now 45 is placed here. Can you follow? So 45, 60 and 92. 92 is placed here. Next removed element is placed before 92 and the next removed element is placed before 45. Okay, is it possible to understand? Yes, because if you partition like this only, all the elements will be arranged in ascending order finally. See, 45, 60, 92. Can you just notice it is in ascending order? 92 is highest element, isn't it? So now you sort the left side for the conclusion. So now the next bigger element is 13 friends, right? So that I am removing 13. Okay, then 26, how I should have to place before 26, then 30, 35, 45, 60 and 92. So finally if you see, all the elements are being arranged in the ascending order. The elements now sorted are 10, 13, 26, 30, 35, 45, 60 and 90. Can you follow? First we are removing the pivot element. All the smaller elements are placed left side. All the bigger elements are placed right side. In the same order, you should not change the order. Now remove the next bigger element and place before pivot. Then remove the next bigger element on the right side and place after pivot. And the next step, again bigger element, place before the pivot in sequence. Again remove the bigger element and place before the pivot element in sequence. So finally if you do this, you will be getting the elements arranged in sorted order. So finally we have discussed about quick sorting algorithms, then we discussed about insertion sorting and bubble sorting, right? I think now you will be having a clear idea about what is the use and meaning of and methodology implemented in using these types of sorting. Okay, so in the next video we will discuss about the remaining sorting algorithms. Suppose friends, if you like this video, I request you to share and subscribe this channel so that many people will be able to get an idea about the data structure topic, friends, right? So bye bye and thank you.